Hello and welcome to my video, lesson 7.2 on solving systems with substitution. So in the last video we solved systems graphically, and although that is a fantastic way to do it, it is not, in my opinion, the best way to do it because you need a graphing calculator to solve it. This is an algebraic method of solving the same types of questions as before, and it helps you understand really what's going on better than the other type. So this is substitution. So if there's a written response question that asks you to solve algebraically, you're going to use this method. This is the best method to solve it algebraically. So let's take a look together at this first example. We're going to actually just put a little bit of space in between, give it a little bit of space so we can try this out. Actually, let's give it a little bit more space. Okay. So here is example number 1. What we're going to do is substitute the value into the other equation. So here we have that x equals 8. So instead of x, we're going to write 8. So what we're going to do is we're going to rewrite the same equation as we had before, except that instead of x, we're going to write 8 in brackets. Okay, so when we do that, we have substituted x, or 8 in for x instead of x. So if you do 7 minus 8, you can see that y equals -1. Okay, so this is a very simple system, and what we're going to do is write 8, -1, so that we can have it in coordinate point system here. And actually, I did not need to put as many spaces there as I thought. We're going to need it more in the next couple. But anyway, so that is how you substitute it in. Now, what happens when it's a little bit more complicated? So here's the next example. X is not just a value. In fact, we don't have x equals. We have y equals for both equations. So this is probably easiest to graph something like this. But it's also very easy to do with substitution, because all we have to do is pick one of the equations. Pick one of the equations just like we did before, and we're going to substitute that in instead of y. So now we're going to rewrite that first equation entirely, but instead of y, we're going to write, instead of y, we're going to write 4x. Okay, now that we've done that, now it becomes pretty straightforward. Now we need to solve for x. Now this is what I always say in my classes: opposite operators, opposite bedmass. Okay, that's what I say every single time we do algebra, right? Opposite operators means if you do addition, if it was addition, you do subtraction. If it was subtraction, you do addition. If it was multiplication, you do division. If it was division, you do multiplication. But it also means if it was, squaring or an exponent, then you're going to square root or root something. If it was sine, then you do sine -1, etc. So those are all opposite operators. So anyways, that is what you're gonna use to solve it. Now this is the tool, okay, but what is the goal? The goal is to get your unknown on top and to get your unknown by itself. Now, this is always what I say, those two things. The tool and the goal, opposite operators, opposite bedmass, trying to get your unknown on top and by itself. Now, for all of these examples today, the unknown is already on top, so that part's done. All we have to do is get the unknown by itself, the x by itself. So we're going to get the x by itself here. So what we're going to do is move the x to the side that has the most x's to begin with. So the left-hand side in this question has 4 x's, the right-hand side has 2 x's. So we're going to move to the left. So I don't like that my keyboard does that, on-screen keyboard. Anyways, I'm going to move that 2x over by subtracting by 2x on both sides. So now I get 2x equals, and then just 3 on the right. Now I'm going to divide by 2 on both sides, and so I'm just going to get x equals 3 over 2 as my answer for x. But as you remember from either the last question or the last video, we don't just solve for x, we need to solve for x and y. So we're going to take that value of x and plug it back in to here instead of, well, actually, better yet, we can plug it back into, no, it doesn't matter. We're going to do it back into here, like I said before. So we're going to plug it back into there instead of the x value. So now we can rewrite that part out again. So y equals 4x, except that instead of writing x, we're writing the new part, 3 over 2, because that equals x. So we're substituting x back in. So now that we've done that, now we can multiply those together. And so you get 2 times 3, so 6, well, 12 over 2, which is 6. So y equals 6. And so now we have those two answers. Now we can write 3 over 2, comma, 6 is our final answer. Okay, I hope that helps you. I recommend you pause the video now and try this next example on your own. Okay, I'm just going to give a tiny bit more space, and we're going to try this out now. So both of these examples you can try, but we're going to do this first one here, and you're going to see that y equals this whole thing. So we're going to replace this whole thing instead of y. So we're going to rewrite that first equation, y equals 1/2 x minus 4. But instead of y, we're going to write, instead of y, we're going to write 4x plus 6. So now that we have that, now we can use opposite operators, opposite bedmass. We're going to move all the x's to the left and all the numbers to the right. So we're going to subtract 6 on both sides. We're going to subtract 1/2 x on both sides. And so when we do that, we're going to be left with, sorry about that, we're going to be left with 3.5x. Is that the best way of writing it? Yeah, I'm going to do that. And negative 10 on the right. Instead of 3.5, can we write it as 7 over 2? Yeah, we're going to do 7 over 2. I like fractions better. So it doesn't really matter, but we'll do this. And then we're going to solve for x by moving the 7 over 2 over. So we're going to times by 2 on both sides and divide by 7 on both sides. So that will move that over. So we'll be left with x on the left and negative 20 over 7 on the right. So that is our answer for x. So now that we have that, we can plug it back in to one of these equations. We'll just plug it into this one. So we're going to have y equals 4x plus 6. But instead of x, we're writing negative 20 over 7. So now that we have that, we can solve it for y. So y equals, and unfortunately this doesn't really solve nicely, negative 80 over 7 plus, and this will be 42. Is that right? 36, 42, yep, over 7. And then we can simplify to negative 38 over 7. And so that is our final answer. So then to write it in point form, you'd write negative 20 over 7, comma, negative 38 over 7 bracket. So these are difficult because it's fractions, but if you find fractions difficult, I highly recommend you go back and take a look at my grade 9 playlist at my rational numbers examples. I've got some good questions in there. Okay, pause the video, try these questions out for yourself. Okay, so we're going to try this ourselves. This is relatively easy because, again, it's solved for x already. The next example is going to be the harder one. So we're going to substitute that in instead of the x that's there. So this is the original equation, but you're going to see that we're going to substitute that in instead of the x. Okay, so that's instead of the x. Now that we have that, now we can just simplify and solve. So first I'm going to expand that out. So it's going to be 9 plus 3y. And then we're going to put the y's together. So 4y plus 9 equals 4. Then we're going to use opposite operators, opposite bedmass, to solve for our y. So we're going to subtract 9 on both sides. And we're going to get 4y equals negative 5. Then we're going to divide by 4 on both sides. And then you're going to get y equals negative 5 over 4. Okay, now that you have that value, you can plug it back into one of these equations. So we're going to get x equals 3 plus y. But instead of y, we're going to write negative 5 over 4. Okay, so now that we have that, we're going to get them both over 4. So it's going to be 12 over 4 and minus 5 over 4. So it is 7 over 4 for our x. Okay, so to write this in point form, we go 7 over 4, comma, negative 5 over 4. And that is our final answer. Okay, this last question is the hardest it can get. Again, pause it if you can. But the big challenging part about this question is that we have to rearrange one of them to solve for y or solve for x first before you can move on. So we're going to solve the second one for x. This is what I'm going to choose to do. You could do whatever you want, but that's what I'm going to do. So to do that, we're going to subtract 6y on both sides. That'll give us 3x equals negative 6y plus 9. Then we divide by 3 on both sides. And that gives us x equals negative 2y plus 3. Now that we have that, this is what we're going to substitute for x over here. So we're going to rewrite that equation out. Okay, exactly the same, except instead of x, we're writing negative 2y plus 3. Okay, now that we have that, we're going to expand it all out. So negative 8y plus 12 minus 2y equals 8. Let's put the y's together so we get negative 10y plus 12 equals 8. Okay, now we're going to move the 12 over by subtracting by 12 on both sides. So we're going to be left with negative 10y equals negative 4. Then we're going to divide by negative 10 on both sides. So we're left with y equals 2 over 5 is our final. Fantastic. So now that we have gotten this value for y, we're going to plug it into x over here. Well, for y, but to find x over here. So that's going to be x equals bracket -2, comma y plus 3. Okay. Actually, we don't need those brackets. And the whole point of this is that we're substituting it in instead of y. So we're going to get rid of y and we're going to put 2 over 5 in brackets there. So what's going to happen is, whoops, wrong color. I want to follow my convention. -4 over 5 plus, and we're going to change that to be 15 over 5 is the same thing as writing 3. Okay, now that we have that, we can solve for x equals 11 over 5, which is our final answer for x. Since we have x and y, we can write this in coordinate form, like that. All right, so hopefully you can see that solving by substitution is, maybe, tedious, time-consuming, but it is straightforward. It is the same steps over and over again. If you follow these steps, you will get to the right answer. It just may take some time. So I hope this video helped you better understand how to solve some linear systems using substitution, and good luck.